to you about how hybrid computational approach reveals particulate matter-related processes. As you know, the modern world is facing many environmental problems affecting all parts of the environment, and the World Health Organization estimates that only air pollution contributes to approximately 4 million premature deaths a year, while about 90% the level of air pollutants is parameters dynamic, topography, number of population, urbanization, and also significant factors are the physical and chemical atmospheric reactions, which contribute to the transformation and the creation of secondary pollutants, and possibility of air pollution transport over the long distances, the transition of pollutants through the environmental subsystem to the multi-phase system, and so on. The challenges in environmental science would be discovering qualitative and quantitative contributions of the main factors which govern the pollution in an area, and these informations contribute to the recognizing the complexity of the environment and also understanding of the processes that lead to increased pollution, and thus provide the ability to forecast for planning, creating strategies and scenarios either locally or globally. What we have, air quality standards are principally based on the limit values of a small number of pollutants, known as criteria air pollutants from directive from 2008. And regulatory monitoring includes the concentrations of particulate matter, elemental composition of particulate matter, and few inorganic and organic gaseous pollutants. From the other side, we have industrial and technological progress, which are accompanied by the emission of much more and a larger number of substances estimated to have harmful effects on human health. Based only on US EPA reports, it is assessed that in urban environment, over 400 harmful pollutants are present in urban air especially. And we can say that situation is much more complex that we can conclude based on actual observation. But values of parameters that represent indicators of environmental pollution have been measured and behaved in different parts of the world for many years. The air pollution data are available at several large environmental agencies, and most of the air quality data is held by United States Environmental Protection Agency, European Environmental Agency, United Kingdom Automatic Urban and Rural Network, National Air Pollution Surveillance Program Canada, and the measured meteorological parameters are also available from National Oceanic and Atmospheric Administration, agency NOAA, but also the values of this kind of data may be obtained from numerical models, which are used for weather forecasting, and this is usually from the Air Resources Laboratory Global Data Simulation System base known as GDAS 1 or 1/2. If we look at the map with marked places where the concentrations of pollutants in the air and meteorological parameters are measured, red and dark blue dots, you can see that this is a potentially large base of available data. Also, we have bearing in mind that these are long-term series of measurements, few years, of the duration of years. What is happening in terms of research nowadays? We have a situation in which experimental research in the field of environmental science is mainly reduced to case studies and monitoring. There are generally small number of experiments involving simulations, control conditions, and so on, mainly because it would require a lot of work and a lot of funding. Also, in the field of data analysis, there is a great heterogeneity in the methods used for processing, data processing, and there is a limitation in terms of resources required to apply advanced model to large data sets. And despite the availability of monitoring data, we have a small number of I can say global studies. The huge potential for progress in the field of environmental science lies in the research of large databases, available databases. The modern moment also characterizes rapid development of software and hardware capacities. So we are able now for interrogation of environmental big data by using advanced statistical analysis, artificial intelligence, and numerical modeling, as well as the modeling hybridization. The need for such research from the point of view of the analysis of available global meteorological and air pollution data using a large number of advanced analytical methods was recognized by the Science Fund of the Republic of Serbia, and they approved 2 years funding for the project Atlas under the Artificial Intelligence Development Program. And the project team consists of physicists, mathematicians, chemists, and how the project is in the field of artificial intelligence. The main part of the team are software developers. Also for the development and application of advanced models for analyzing large databases, high-performance computer paradox placed in the Institute of Physics, Belgrade, is included. The aim of the research is to take a step forward in relation to the current methodology of data processing, to the modeling of space-time data and processes related to global fate of the air pollution, air pollutants. Also, one of the goals of the Atlas project is harmonization air pollution research through facilitating access to available data, data analysis, research, and at the end exploitation of the results. Everything through the user-friendly software platform. We think that this will increase the efficiency, creativity, and productivity of the research while supporting multidisciplinary and leading to an in-depth understanding of the processes that lead to air pollution, and we hope at the end better environmental policy and strategies. I will show you only a few examples, the results of contextual and synergetic modeling of particulate pollution, primarily based on the application of machine learning models and explainable artificial intelligence within the Atlas software platform, and the results were obtained within the project's air quality plan for the cities Belgrade and Novi Sad. We used the concentration and meteorological concentrations of pollutants, air pollutants, and meteorological data from the Belgrade area in 3 years period from 2017 to 2019. And the first diagram represents the influence of the meteorological parameter temperature on PM10 concentrations in the context of sulfur dioxide concentrations. As you can see, at the temperatures below zero, this parameter contributes to an increase in PM10 concentrations by an average of about 10 microgram per cubic meter, which may be the consequence of impact of intensive combustion of fossil fuels for heating supplies. In the ambient of the high sulfur dioxide concentrations, this increase may be as high as 20 microgram per cubic meter. You may see red dots at the left side of the diagram. This may be associated by using fuels with high sulfur content. From the few degrees above zero to about 25 degrees, the effect of temperature on suspended particles is insignificant, while during the warmer weather, during the spring and summer temperatures above 25 degrees, it is evident impact of temperature on increasing PM concentrations, but this time about 4 microgram per cubic meter. This may be connected to the processes of particles resuspension. Second example represents the analysis of air pollutants and meteorological data from the Novi Sad in the period from 2018 to 2020. Left diagram shows three regions of the influence, of planetary boundary layer height on concentrations of suspended particles PM2.5. We may see the three different regions, and the first area is the domain of the greatest influence of PBL height on the concentrations of suspended particles in the environment of lowest height of PBL up to 100 meters. Reducing the height of PBL below 100 meters can affect the change in concentrations by about 10%. For the heights of the boundary layer from 100 to 500 meters, it can be considered that its change does not greatly affect the dynamics of suspended particles, while from 500 meters with increasing height, the concentrations of PM2.5 decrease to about 10%. Also, in the environment of low planetary layer heights, the high concentrations of PM2.5 are followed by maximum concentrations of carbon monoxide, and it speaks us to common source of these two pollutants in the urban environment. On the other hand, stagnation and decrease in concentrations of suspended particles in the environment when PBL heights are above 100 and above 500 meters are not accompanied by decrease of carbon monoxide concentration by the same dynamics, which may be due to different nature of these two pollutants. I think that these results are important because PBL height represents a significant meteorological parameter with pronounced dynamics on a daily and seasonal level, and also significant influence of the concentrations of pollutants in the air. Detection of these kind of non-linear effects of this variable on concentrations of pollutants in different environments and records of the effect at quantitative level is of great importance, and primarily for prediction, pollution, planning, and even the adoption of measures and regulations in the field of air quality protection. The nonlinear relationship between carbon monoxide and PM2.5 in the context of sulfur dioxide concentrations is shown in the right diagram. And in the environment characterized by an increase of carbon monoxide concentrations, an increase of PM2.5 concentration is also observed. And such connection indicates the common sources of these two pollutants, depending on the intensity of which the concentrations of pollutants also vary. The environment determined by the concentrations, one interested region, the environment determined by concentrations of carbon monoxide between 0.7 and 0.8 0.7 and 0.8 milligram per cubic meter does not clearly lead to the observed lower or higher concentrations of PM2.5. And these results in some next step would need to be investigated in more detail, primarily in relation to other variables, because CO and PM2.5 are subject to different chemical transformations and participate in different reactions in the atmosphere. This was just one part of the preliminary results I wanted to show you on this occasion, and a lot of work is necessary and expect our team on the development of the Atlas platform. Some of operational tasks are development of sufficiently intuitive and user-friendly interface, which will be able to adopt other types of data upon completion of the Atlas project. We are also aware of the fact that the understanding of the processes related to environmental pollution has yet to be improved on the basis of data-driven research. Also, at the last slide, I'm presenting you graphical interpretation, graphical presentation of Atlas platform and how we envision that it will work in the future. The scientists only make this. Thank you for your attention. You will be able to listen more results from my colleague Andrea in Wednesday.
Thank you, Mirjana. Are there any questions to this presentation, please? Just to check. Yes. Yes. Yes, Elena. Elena, please.
No, she's.
Yeah, thank you. This was really nice. I think this is the type of initiative that is really needed. But I would like to know, is this based on only Serbian data, or do you plan any relations or any use of like international databases and international initiatives, of which there are many, and of course that would make it a little bit complex, but still considering the requirements of connectivity, that may be worthwhile.
The examples I show you are data from Belgrade and Novi Sad, only from Serbia. But our plans are to analyze data from Europe, from US EPA, all available data. We have a database, I don't know how large it is now, but all data from US and from Europe.
Okay. Thank you.
Thank you.
Zorana also message that it is a nice presentation and work, and Saverio as well, and it is really great job, and hope that it will be more.
So I have a question too.
Yeah, Saverio.
Yes. First of all, thank you for the really nice presentation. And I would I'd like to ask if you plan to include in your data streams, relevant data streams, local census, and how you plan to assimilate, let's say, this data to your infrastructure.
Now we are, our plans are to work with available data from reference measurement methods. We are not closed. We are open for new data, for different kind of data, and we will see what will happen in future.
Thank you.